take minutes or maybe a few, maybe an hour or two to have a very large environments deployed ad hoc. So when the business needs to deploy something, now we have a lot of demands that you need to deploy something in your dev test environments, in your production, and at the same time, you don't have availability to do it manually like you used to do. In this case, you can use the automation tool to make sure things are done quickly. So in order to achieve this operational excellence, you need to collaborate. So for example, you need to have visibility for what you're doing and share it with your team. So their team, they have their visibility and they can add their inputs to what you're doing. Assume that you don't have that much experience in security, but you know how to develop something in infrastructure as a code. You have Terraform experience or Bicep or whatever, and you publish something. But you need someone from security also to review what you're doing. Maybe you leaked something. Maybe you put credentials inside your code that you're going to deploy, which could be a risk. So you need to collaborate with other teams. You should have visibility. They should have their tools to review before it's been approved by someone else who is releasing and allowing this to go through production or whatever. So this kind of operational excellence or collaboration is required when it comes to infrastructure deployment. Okay, so in order to do that, we need design and build and orchestrate with modern practice. You need to use a kind of monitoring that can alert and give you analytics about what you are doing and what you have deployed. You need to use automation as much as possible. So instead of doing things manually, you can go with tool and unit test. So one of the modern practice that we'll use is infrastructure as a code. So infrastructure as a code is not something scary. You can even start deploying small things using a very lightweight script you develop by yourself. You can just follow the same architecture, how this template is being built, and you can start and build it using your even on permission that you have in production. But instead of doing things manual, you can do this script. So what infrastructure as a code can provide to you, it's a declarative language. Means you don't need to understand deeply how the resource is going to be deployed on Azure. Either it's AI or let's say SQL database or virtual machine or storage account or analytics, whatever. You need only to tell the infrastructure as a code, I wanted to deploy this model or I wanted to deploy this virtual machine with these requirements and these specifications. How this will be provisioned and created, this will be something taken behind the scene, and you don't need to do how this gonna be done. Just you need to declare it what you wanted to deploy and then just run it, and then the resources will be created for you using a lot of things at the back end that you don't have visibility to. And also, idempotent means that if you run the same script again and again and again, the result should be consistent. It should be always the same. So it doesn't mean that when you run something and someone else will run it the same, he will get a different results. It should be the same. And also versioning is very important. When you deploy a script that will be run to provision and deploy things in your environment, it will be through a maturity level. So today you started deploying a very small environments, but maybe after 1 week, you need to add and enhance more in your code. So this will be a kind of versioning that you have version 1 release, version 2 from your script will be released, version 3, each time a new version of your scripts will be released. It will go through a kind of a check, like from security perspective, if it's gonna break something in your environment or not. So you need to do a lot of sanity check before you release something. That's why it goes through the versioning. If you found that this version causing issues, you can at least revert back to the previous version of your code and redeploy it if it's required. And reproducible means you can always reuse it again to reproduce services. So when you create a script that, like we will see in the demo, you shouldn't put some like static variables inside. You should make it variables. You should make it very, let's say, carryable by others that they can use it and they can just use it for their own purpose. For example, you wanted to deploy a storage account with some specific requirements. One VNet, for example. You know what is VNet, right? VNet and some. So when you deploy a new storage account, you should provide some information to the script that make this storage account created in a different VNet. Okay? Could be with different configurations. Maybe the storage account that you are going to create using the same script needs to be publicly accessible through the internet. So you need to pass some variables to your script to make some changes in the code. However, it's the same code, but when you pass some variables to the code, it will do something different. Okay? Automated provisioning and the configuration and distributable. Let's go through the IAC tooling that is very common and used by most of the technical guys in deploying and managing. So there is actually two phases when you deploy something, right? You want to deploy your environment, and also you want to manage it afterward. So you can use the tools to do the deployment of your environment, something like Terraform, like Bicep, like even PowerShell, okay? Whatever the technology that you are comfortable with to do, it could be enough for some environments to do everything from A to Z. For example, you can use Terraform to deploy things, and also you can use it to manage your environment. Like the life cycle of your resources, it may go through some phases. Like for example, you create it, you use it, and at certain point of time, you modify it, and later maybe you want to delete it. You want to delete this resource. It could be created for a small project for 1 month, and then you wanted to delete everything. But during this month, you may apply some changes to your infrastructure. So Terraform can play this role simply. It can do the provisioning, it can do the changes, and then at the end, you can simply destroy whatever you deployed using Terraform. But doing something further, like, for example, to manage the image that you wanted to deploy on a virtual machine, and you wanted to do it in a very efficient way. So you need to do something else, like, for example, HashiCorp Packer. Or you wanted to manage your environment using something like Ansible or Puppet or whatever. So you can have whatever tool after you deploy your infrastructure using your code to manage, or even you can use the technology that you use to deploy. If it's enough for you and your business need, you can keep it as the only technology that you use for creating and managing. There is, yeah.
I have a question on that slide report. What are the factors that we should consider in selection of the tools?
Yeah, it's a good question. So let's go for
mainly for this Ansible and Terraform. That's
yeah, Ansible. Yeah, Ansible usually it's used for desired state configuration. Like you wanted to maintain a configuration, you wanted to apply some specific configuration on your environment. So it's usually used to manage your environment, not to deploy your environment. In Terraform, usually we use to deploy environments, okay? And then you can use different tool like Ansible to do this kind of management. But this is it's not considered infrastructure as a code because you used Terraform initially to deploy your resources. Okay? So it's like, for example, PowerShell desired set configuration, where you can push a specific configuration. You want to ensure that your servers, it always meet this requirement. If any deviation happens, it should shift back and move to the standard or desired state configuration that you're making. So for infrastructure as a code or deployment, we usually doesn't use Ansible. We use Terraform, Bicep, or ARM.
We don't use Ansible for the newly provisioned resources.
Terraform
or for the discovery or for this compliance. We normally use Ansible.
Right. So the measures tree, it's not only those, but this is the most famous tool that we use: Azure ARM, Azure Bicep, and Azure Terraform. Today we will cover some of the Azure ARM and Azure Terraform. I decided to skip Bicep because it's very close, like it's like ARM and the Terraform. But the only thing is the ARM is different in the structure, but the concept is almost the same. So that's what I was discussing. Your environment could be mutable or immutable. Okay? So mutable means can be changed after creation. Immutable means always destroyed and recreated for a change. So sometimes your environments, when you wanted to make a changes, it cannot be changed while it's running. For example, you need to change the size of VM not available for the SKU that you selected at the first place. So in this case, you need to recreate your resources again. You need to delete and recreate. Or for example, you need to change something, some attributes that is not changeable on these resources. So you need to recreate. Some resources, it's flexible, or some attributes, it's flexible. You can change it, and you can do it while it's running. It's not impactful. Okay. So the most common one, and I myself, I use Terraform most of the time. It has a lot of advantages and some disadvantages, like, of course, like any other tool. The good thing in Terraform, I don't know if you already played with Terraform before or not, but this is a tool that's created by a company called HashiCorp. So this tool is not specifically for Azure. It's for a lot of services that you can use to provision and create your resources. So for example, if you wanted to create a project that it will create some resources on different hyperscaler, for example, on Azure, at the same time, it will deploy some modules on GCP or AWS, or even on-prem on Kubernetes or any other, or VMware. So the good in Terraform is that they are providing a providers that can allow you to develop a code that can be run on a different technology. So they are not actually specific technology oriented. They are developed their language, their own language is called HashiCorp Configuration Language, HCL. And this is what you can do to deploy whatever the resources that you want across any platform or any supported platform. So the point is why I use it for Azure, okay? Because it's very easy to use. Second, Microsoft works very closely with HashiCorp to publish and ensure that all registries are published and it works, it doesn't have any problem. And they work together always to publish the new resources when you introduce a new services. For example, we work very closely with HashiCorp to ensure that they already publish a new provider or updated the providers to work with the new resources. So this is advantage and also disadvantage at certain point of time. For example, it could be a recent released service from Microsoft that is still not included in HashiCorp or in Terraform. In this case, the Terraform will not help you to deploy something, to deploy this service specifically. You have to wait until it's published and released, and then you can update your code to deploy it. So it will be like a little bit gap before things that's been released by Microsoft and all available on. It's not, sometimes they release even before the preview, but it could happen like you have something released, but it's not yet updated in HashiCorp. Okay, so you can start even if you haven't ever before created any resource using infrastructure as a code. You can simply start create your code with very less efforts. What you need to do is just to install the Terraform on your machine and sign into your Azure, and then start to develop something even lightweight. Okay? So don't look to the huge and complex scripts that is on the internet. Someday you will reach to this level to develop or interact or modify, but also you can start immediately develop your own scripts that you can use for you to make your daily life easier. Okay, so as you see here at the top, the first thing that you have to provide, this is like JSON. Okay. And so the format here is very readable by us, by human. It's not like programming language that is very hard to be understandable. It's very English-like discussion key values. So you can easily understand any script that's being provided or published on the internet. You may need some understanding of which resources you are going to deploy in order to deploy it in a proper way. So for example, here I use Azure ARM providers, means I tell my Terraform, I'm going to deploy a resources, but it's on Azure. So the first thing that you have to tell your Terraform template is which platform the resources will be created. So you have, when you create this script, you tell Terraform, wherever you run the Terraform scripts, you run it on your own machine, you run it inside the DevOps or GitHub action. It doesn't matter from where you are running, on any virtual machine running wherever. You can just simply tell Terraform, I'm going to deploy these resources for Azure. For any other platform, you have to include the proper providers. If you are going to deploy something also on AWS, you have to provide the provider of AWS to your code. Clear? Second, you see here that I'm going to create a very simple resource. It's a resource group. Okay? It's a very simple thing. Resource group. Okay? So see here, I'm just telling Terraform I want to create a resource from Azure RM resource group. Okay, and then I give it a name. This name is only as a reference within my code, which means later on in my code I can call this storage account and get some attributes. Like, for example, the size of this storage account, I need it for something else in my code to do further action or as a variable later on. So I can use this, the example here, you can replace it with something that is only visible for your resources within your code. But name that the second line, the name is what the resource group will be named on Azure, right? And then the last thing is location. So this is the minimum that you need to provide for Terraform scripts to create a resource group on Azure. Means that you have to understand for each code you run, what is the minimum requirements and what other variables that you can use to enrich your script. So you can see afterward the SKUs, you can see the encryption, you can see it's the blob, the containers, whatever you wanted to include in your storage account that you will create after in later on. You just need to go in Terraform and go to the documentation and define this module of this resource type and find all properties and attributes for this one and see the value that it accepts for each one. Otherwise, your script will not be applied because you may provide a string value to something that should accept only integer answer. Okay?
There is nowhere we need to put Azure subscription or client ID, those details.
Yes, this is actually, you have two ways to do that. Either you provide the credentials in a secure way in your code where you can create this as a file, a simple template file, and you put your credentials inside. And then when you run the code, it will use this Terraform script or Terraform template to authenticate and create resources based on the credentials that this account has. Or you can just sign in to the terminal using your Azure credentials and just run the script, and it will take the context and run the script against your subscription and provision the resources. Which one is best? Definitely to secure your credentials in a central way, and then you can provide. And usually you should use something like a service principal instead of providing your credentials. So you can simply create a service principal with a proper permission. And when you run the script, you use this service principal to run the script. So the first thing, once you have applied this script, it's simply when you go to the resource group, your Azure, you will find this is already created. Okay. Yeah, sure.
I'm not really familiar with.
Sorry?
I'm not really familiar with like why we're using code instead of just going to the website and doing it. Does this have to do with like automation or what's the objective?
Yes.
What we're doing.
I already explained that at the beginning. Okay. Let's assume that you got a job or a task from your organization. We need within 1 hour, we need to provision an environment that has a cognitive service, AI running with Cosmos DB, with a storage account, with app services and functions. And we need this very fast in 1 hour because we are going to train something or we are going to deploy something. How are you going to do this with using Azure Portal? First, it will take a lot of time, definitely, right? Because you have to go and go through each wizard step by step. And secondly, you may do a lot of mistakes. You forget to do some configurations, or you may make also security risk because you forget, for example, to disable public access for some specific services like storage accounts or Azure Analytics Workspace or whatever. And last, if you want to repeat the same again, you have to repeat all the steps from the beginning and do the same task for the dev and test and production. So they ask you to provision 3 environments, but in production, we need to have higher SKUs than the one we use in production or dev test. So that's why I'm telling you, when you build your script, make sure it's reusable. Means you can make the same script, but with some variables that make the script behave differently when you provide or pass some different variables. Like, for example, the SKU. So if I want to deploy in production, I may need to use higher SKU to accept the production. Or maybe for dev test, I will use smaller SKUs. So the same script that it will deploy the version machine will do the same, but with some variables I provide. If you want to do it manually, good luck, you will lose a lot of time. You have to repeat your work again and again and again, and you'll do a lot of mistakes.
And simply just to create parameter file, you have different variables. You deploy the template with different parameter files.
Thank you.
Clear?
Yeah.
Okay. So see here, like here, for example, this is a simple template. I may call it like, by default, we name the default or the entry point of our code main.terraform, main.tf, which is something you can use, something like this is one way. Sorry for very small fonts, but this is a symbol, not symbol, sorry, it's a sample of how the scripts can be very huge or it can be very simple. So as you see here, it's not only one script, it is a lot of modules that compose together to install one large environment that has a lot of components inside. So you can start your project only with 4 files until it reaches to something like this. Right? So you can use any editor as long as you are happy with it. You use Visual Studio Code, you use any editor that you are happy to create your Terraform templates, and simply you can easily deploy and troubleshoot and fix and apply and destroy.
Next control plus.
So this is, for example, I used to first navigate through the folder where I kept my projects running. Okay, so this is one project that will deploy Azure Cognitive Service. Okay. This consists of a lot of modules that deploy a lot of other components within my code. So simply this code, this Terraform project, I will pass some very few variables to my code in order to deploy this in a proper resource group and also using the proper configuration that I'm looking for. For example, I can provide, it will ask me to provide which model, which AI cognitive service I want to deploy, OpenAI or any other. For example, it will ask me which SKU you wanted to use, S0, S1, depends on my first option I select. You're gonna ask me for the location where I wanted to deploy this service. It may ask me for the resource group where I wanted to deploy the services. After that, it will go and deploy the resources to my Azure subscriptions. We'll come to this later.
Thinking that hurting your back, maybe you can sit and it's easy for you.
Oh, no, it's fine. So you can start the Terraform project only with 4 files. The first file is the main.tf. You can create this file using a text editor or Visual Studio Code, doesn't matter. As long as you maintain the proper syntax and the architecture of your file, it's fine. You can use any editor. The good thing in Visual Studio Code that it will check your error syntax, anything, and it will provide you forget this column, you forget to close these brackets or whatever. So it will make editing the Terraform code easier for you. So the first file is main.tf, where you keep the entry point of your project. So this is one, for example, just the provider is AWS, and the region is variable. So see here, in my code, I haven't provided a region. Okay? I didn't hard code this region in my code. I will get it from the variables. Okay, so the second file that I need to have is variables to Terraform, for example. So in the variables, I define all the variables I need within my project. Okay? And this is very small project. So for example, I defined a variable called AWS region, or instance AMI, or instance type, or bucket name, whatever, regardless where you are going to deploy and what is the resource that you're going to deploy. Then the third file is the terraform.tvars, where you can, how exactly you can provide this variable to your code. When you run the code, you have to pass those variables to your, when you run the code, you can say var and just mention the variable name and the value that you wanted to pass to this variable. And then it will be taken to the main TF and then run the script accordingly. But maybe you need to hard code also those variables in a file, where you can always want to use the same value. So in this case, you can create this file, terraform.tvars, where you can statically provide the variables. Right? And then you have the output file, where actually it will talk to you once the resource is being created. It will provide some output. For example, the instance name of the object that you created. So you can take this and you can save it for logs and use it later on. So this is simply how you can start the very lightweight projects just with 3 files, and the others will be, the last one will be created automatically. Is it clear so far? You have any questions?
Yes, for variables, can it be like in real time?
Yes.
Example.
Yes, yes. That's what I'm saying, that when you run the script, you can pass the variables in real time, and then the script will understand that you wanted to match this value for this variable. And then when you run, it will take the variables and run the code using whatever you provide. And then your projects will look much different when you start having more modules. Like your project is not only to deploy a small storage account, but also virtual machines, and also VNets, subnets, and a lot of private endpoints. A lot of stuff will be created within your project. So maybe you have like different teams that they are support, or they should develop different parts or artifacts within your project. So you can just combine their efforts in one project, or you can do this also for yourself to make your script readable. Instead of having everything in just one Terraform file, you can distribute your scripts across different modules and call it whenever it's needed. Okay, so you can call it like you have like a central location where you can call different modules whenever it's needed. So not always you wanted to create with a storage account, you wanted to create a private endpoint. Sometimes you need private endpoint, sometimes not. It depends on what the storage account is for. So if you need a private endpoint, then you can call the file for private endpoints. Otherwise, you don't need to do that. Just you create a storage account with the default settings or with different IP rules you apply on the storage account. Okay. So the core Terraform workflow is easy. Write the code. Then you need to initialize. Initialize means first you need to write your code, and then you have to connect and tell Terraform, this is my providers. This is exactly how I want to deploy my resources. And then Terraform will initialize and prepare the folder on your machine. If you run the scripts from your local machine with all the providers and files and licenses and logs that you need to run your scripts in production. So without running this step, after you write the code without init or initialization, you will not check. I haven't done with this one.
Not this one. No, definitely. I think some click has happened. Let me check that. Incoming. You just your mic and mute. Disconnect and reconnect. Reconnect to them. Share your screen. No. Check now. No. No, it's not going on. Okay. Go back to the here's the settings from here. Like this one. No, this one like this. Yeah. Can you present again? Is it fine? No, you can continue. Yeah, you continue. Yeah, you continue.
Okay. So the first step is you write the code and then you initialize the code, where your Terraform will download the required files locally on your machine, or if you run this on the repository like on GitHub, then you initialize this on whatever the platform that you run the code from. So if it's on your laptop, or it's in your server, or some virtual machine running on your Azure, then initialize will download those locally to your machine. And then within the code you declare, you already define what resources you want to create, and you also pass some variables to your code, right? As we saw in the previous example. And then when you run plan, this actually will do a kind of checking. If I'm going to deploy in production this code, comparing with what you have on Azure in reality in production, and then it will generate the plan, which means let's assume that you wanted to create a VM on a VNet that it doesn't exist. Right? So you define the VNet name, but you haven't created this VNet as part of your project. You just created the VM and you said, I want to create this VM in this VNet. But when you do the plan, it will go and check existence of this VNet. It does exist or not. If it doesn't exist, it will give you error that you are trying to create a VM in a location that doesn't exist. Or even maybe you have something wrong in your syntax within the code, or you forget to provide the providers. A lot of things that make your code, when it's run, actually, it will not run, it will make an issue or a problem. So plan is the first step before you go and deploy in production. It will simulate using the real information from your production, and then it will compare what you wanted to deploy, and then it will provide eventually this will be created. For example, assume that you create a project using Terraform template that it will create VM and the storage accounts. Afterward, you've already done the script, you run it, and the resources are being provisioned successfully. But afterward, you deleted these storage accounts and you rerun the code. What do you believe that it will happen? You rerun the same code you ran it before to create two resources, VM and the storage account, but you deleted the storage account and rerun the same code again. What do you believe will happen? No.
Nothing.
It's a storage.
No. It will not throw an error, and it will do something.
Create the storage account.
Exactly. So the first thing, it will compare what this script's meant to do. It should deploy two resources on Azure, correct? One of them does exist, similar exactly like you wanted to create in the script, and the one doesn't exist. So it will simply say, okay, when you run this script in the next step, I will not create a virtual machine. I'll just create the storage account that is missing right now. It will not recreate the virtual machine because it already does exist with exactly the same configuration you want, but it will create what is missing. So this is the idea of what we do, the state or the plan first, to compare what is being in production with what you wanted to deploy, and then it will make these differences and then create whatever is missing. Or it could be you make in the same code exactly, you pass the new variable, for example, only to disable public access for your virtual machine or your storage account. So in this case, it will not recreate the virtual machine. It will just do the small change that you wanted to do is disable public access. Okay, simply like that. So that's the benefit of having this plan running.
So what about scaling it? Scaling out, for example, I'm creating a storage space or a virtual machine with some parameter. Yeah, I'm recreating the same resource but with different parameter. Will it scale out or in? Same like the changing from public access or not, or it will just throw an error.
Yeah, it depends if this resource is, as I told, immutable or immutable. Means that the change that you want to do, it can be done on the resource without deleting it or not. Changing the SKU for some resources, it can be done while the resource is not destructive. And for some resources to do that, or the SKU that you are looking for is destructive. It means you need to delete and recreate. So this depends on the case, what exactly you are going to do.
But Davi, will it also tell us that these are mutable or immutable?
Yes. It will tell you when you run the plan, it will tell you exactly what it's going to do at the next step. It will tell you, I'm going to delete or create or do. Like, for example, you have something that you removed from this script, you remove the virtual machine from the script, but the virtual machine does exist. If you rerun again the script, it will understand that you wanted to delete this virtual machine from production. That's why it's very sensitive. When you do something, make sure you first do the plan and see what action is going to be done. It will give you like,
where's the state being maintained?
Hmm?
How are you maintaining the state?
There is a state file. It will be created. If you run the script from your local machine, it will be something called the state file. This state file will keep tracking for whatever you're doing. And this is very important to be always available. If this state is not available, you cannot run the same script again. Okay, so it will run as if it's something from scratch. It doesn't understand what you have done before and what is the status of your production, right?
So it keeps all the track of all the changes.
Yes. It's called the state file that you keep wherever you run the script.
So if I want to modify a resource, I cannot rerun the same script with different SKU.
Yes. You can run with some configuration. You can do whatever you want to make it a change. If it's not destructive, then it will tell you the change you've done. I can do it by delete and recreate or by just update. So it will give you three things: creating, deleting, updating, whatever.
Now, one other thing, usually when the organization is working on, let's say, for VMs or things like that, they define some standards. The VM should already be defined like this. So usually what is the practice? Like each organization have their own like top level information that this is how the module for VM should be there. And then for project specific, they only pass parameters, or each one starts from scratch. So how that works?
So usually you use the same script, but with different variables. Right, so you can run this script with this variable or with this parameters file. So these parameters will make this script behave differently when it's in production or it's in dev test or in whatever maybe sandbox.
Like the question is usually like if I'm a developer and I'm trying to deploy this, will I always import the code from like say the verified modules, or will it always in my corporate directory that these are approved images or these are the approved script and I can only import from here?
This will come to DevOps process for this. So this is exactly a DevOps process. So where do you want to keep these scripts, how you want to maintain it, and how you want to run it on an enterprise scale level. Okay. And then we have the apply, and this is where you do the change actually to physically to your production. This is the most important part. Okay. So provisioning with Terraform, day 0, you create the resource. 1, you make some operation. 2, etc. And maybe at a certain point of time, you want to also, this is exactly your questions, where it will keep the state of your running script. So this will be in the TF state, and plan will be kept in the TF plan files. Okay, you can make, as I told you, you can make any updates. So in your main Terraform files, you make some updates, you run the plan, TF state will be updated with the new changes, and then you can apply it one more time. And then at the end of life cycle of this process or this service, you can easily terminate it by plan and run destroy command. And then instead of creating, it will delete whatever in the scripts that's being created. Okay.
Can we have some gates in the middle for like review and approval?
This is the last slide, the DevOps. Okay. So we'll come to this point. Okay. So this is the Terraform in very simple explanation. You see, I will show you also from where you can get very complex Terraform scripts for your projects. But for ARM, it's a different technology. It's pure for Azure. Means you cannot use ARM to deploy AWS or GCP resources. It's only for Azure resources, not like Terraform, where you can use the same Terraform to deploy across different hyperscalers or different platforms. So it's also used like JSON-like format. Okay. So it's also used a declarative syntax where you don't need to details how you want this resource to be created. Easily you can just define and then run. You can use repeatable, you can use orchestration. It's similar like Terraform, but it's lifetime. It's always to create resources in Azure. Also, it's modular. You can create any Azure resources. This is the major difference between it and Terraform, that you cannot, it will not happen like there is a service on Azure. You cannot deploy with ARM. It could happen with Terraform because it's a different company, but it never happened with ARM because always resources used ARM to be provisioned. Okay. This extensibility is also something you can use with Terraform. It's not something unique for ARM, which means the Terraform itself, it doesn't actually, when you create a virtual machine, it doesn't go and configure the virtual machine itself. You may need, when you provision a virtual machine, to run also some PowerShell or some scripts inside to install and disable or enable some services, make your VM ready for production or ready for other functions. So you can extend your the boundaries of your script by running also something like scripts. So you can just define your script and tell, while provisioning this VM, run also these PowerShell scripts at the backend. And this is something also you can achieve with Terraform. So it means it's not a capability in the ARM, but the capability is to run something else that make your VM ready. Okay, could be Bash script on Linux or PowerShell script on Windows, whatever. Also, there is something, a tool is for testing. Okay, this tool is very useful. That when you create, let's have it here. Okay, so you develop something on ARM, you spend some time on it, and you want to ensure before you deploy it. Sorry.
Not magnified.
It's not in the present. I'm sorry for this.
Can you search magnified it? What you seeing there?
So this actually tool is built by Microsoft. You can download it free. When you develop something on ARM, you may need to ensure it is not actually missing something, or the format is correct and doesn't have maybe security risk inside. Okay, so you can simply run this tool. You can download it and run, and then you can just provide. JSON. Okay, and then it will go and scan my script and find any. It will do a lot of sanity check and give me green, which means secure parameters in nested deployments. I don't have any issues, but that's why it's green. Secure string parameters cannot have defaults. I have green, means I don't have any string parameters, secure string parameters passed. And you find sometimes it's red, means I have something missing in my scripts that I need to fix. Okay? And this is all before you run your ARM scripts in production. So you can have some visibility on what could be the best practice. And this tool is updated, means it will provide you the latest recommendations.
The baseline of this validation is something that Azure standards.
Yes, Microsoft standard.
Can I apply my own organization standards, my own policy and procedure, my own governance? Can I apply it?
Yeah, when it comes to the governance, this you can develop your own tool, for example, because it's a JSON file, right? So you can go and check whatever against you, whatever you define. But if you have like something customized, like we'll see like how you can also use policies and Azure policy, and also Microsoft Defender for Cloud, for example, where it can go and scan your code for some security risk. So there is some technology that you can use out of the box to integrate with your IAC development lifecycle, or if you wanted to have something created by yourself within the GitHub pipeline that will go and check this JSON file for some specific pattern or syntax, this is something you can do. But this tool is very helpful because it will do this sanity check before you run it, or you even in the development phase. So you develop this and you give it later on to your DevOps team to upload it and then deploy it using the pipeline. So you need to do it. It's like on your machine, you can do this kind of. Now I have, how do I exit from this again? You know how to exit from magnifier? Okay. Okay. Present again. Okay. So this is simply a sample of ARM. Okay. We said you can test it. You can build in validation. Your template is deployed only after passing validations. This will be done when you run the script on Azure. Policy as a code, you should also consider policy always when you run even infrastructure as a code. Means it could happen like when you deploy your IAC or develop your IAC, you make something very destructive in your environment. It could be deleting something, or it could create resources, for example, that you're not supposed to create in this location. That it may increase the consumptions dramatically, and you find you made something mistake. So to have some guardrails and boundaries, you should also consider using Azure policy always. So this is like a second layer of defense after you have your pipeline, CI/CD, whatever the way you deploy your script. You still need a layer of defense to ensure that you're not deploying something that is not acceptable by your organization. So this is how Azure policy will do this. So it's like the bigger boundaries that you are allowed to create multiple SKUs, but you are not allowed to create this SKU in India region, for example, or in East US or whatever. So this kind of things, or you cannot create or give this virtual machine in production a public IP, for example. This kind of restrictions, even if your IAC code going and create a VM with public IP, the Azure policy will restrict this behavior. Okay, so it doesn't mean that you have the powerful to create something that you are eligible to do it as long as the policy is against it. Okay? If this is something that in your policy you wanted to do a remediation, then the remediation will be done for your resource. It depends on how you define your Azure policy, if it's deny or remediate or what, or just a compliance report. Okay. And the good thing also in ARM that you can track the deployments. It will be in the deployment tracks. The good also thing in ARM that you can easily get ARM templates from your production, which means you can just simply open your Azure portal.
Export template.
No, you cannot export from Azure portal to a Terraform. You need to convert it to something that like Terraform likes format.
But I have seen an article that recently export a template for a VM. Now it's accessible for a Terraform. I don't know if it is accurate or not. It started like reviewing in Microsoft.
Maybe yeah, it's something maybe
Because usually when you go to export template, you know, it just like show the ARM template. Because maybe I'm working on Terraform and I want to collect all my project, like to have specific Terraform for a landing zone, for example. I want to collect all of this. So
it isn't.
Yeah, I've seen this.
Yeah. But yeah, that's a good.
It's better, like
Yeah.
better, more work efficient.
So, for
you
example,
state with ARM templates, state file. Can you manage the state like we do it in Terraform?
no, with ARM template, once you deploy, the resource is being created. But when you do a change in this ARM templates, it will check first. It will not recreate again. For example, the state of this will be achieved once you rerun the script one more time. It will check the missing configuration compared with what you are trying to run, and just make this a small configuration. But there is no state file.
Yeah, but what if I delete a component from the script?
It will not delete in production. It's not like Terraform. Okay, so I can go here, for example, this is like source where export template. And then easily I can get ARM template with parameters for this resource, which means I can just extract it, store it locally, and then I can do some development on it, and then I can recycle it and use it later on to create a different resources. Okay, so this is one brief location where you can easily get of course, you need to do something like parameterize and create the variables, and you cannot just take it as is and rerun. You may need to revisit and make some changes.
By the way, ARM template is all the deployment in can include the JSON file. So even if you have Terraform at the end, it will be converted to a JSON request on the same device.
Yes. And even bicep eventually it will be translated into ARM.
You can't decompile ARM to bicep.
Okay. So this is templates. Right? It has in ARM template, it has these 5 sections. Parameters where you can define parameters, variables. You can create your own function, user-defined functions, resources that you want to create, and outputs where the results after you create the resource will be stored inside. So for example, in this template, you can define some parameters like storage name, type string, minimum length 3, max length 24. And then when you run your script, you can just simply pass this storage name as part of running the script. Okay, so you don't need every time you run the script, you don't need to change within your code. You just need to pass the variable, which is the storage name. And this is also the variables where within your code you can have sorry for the fonts, but this is how you can within your code, for example, the storage account name, it could be concatenated with from different using different things like resource group name, for example. So you can make a variable that it can concatenate some prefixes plus the storage account name plus also a prefix. The good thing also, you can integrate your ARM template with Key Vault. For example, when you create a VM, you don't want it to provide the admin password within your scripts because this is a very sensitive information that you pass and keep it in a plain text format. So you can integrate your ARM with a Key Vault where you keep the password of your admins. And then when you run the script, you just need to connect to this storage account as part of running the script, retrieve this password, and provide it to the script as account or the admin passwords. You can use it for anything that requires credentials like SQL or VM or whatever. Okay. When you design your templates, you can consider having 3 tiers templates. It means one template can create multiple resources, or you can have that one is this stick. I mean, the second one is one parent, but it has some listed templates. So you have one template for creating virtual machine, one template to create app service, and one template to create SQL database. And you have parent template where you can either tell which resource you want to create, and it will go in the call this linked template to provision the resource that you're looking for. The third one, this is the same image, but the third one is to have a separate template for each resource. Like for virtual machine, you have your own template, for app service own template, and SQL, etc. Okay. Now we already see how it's easy to create ARMs, from where to extract ARM templates, and also for Terraform, I will show you also something initiative by Microsoft. Now you see here that you may have something like that. It's AI service deployment. So this is usually like a same architecture you always wanted to deploy in a modular way when you have a project on AI service. It could be in production, whatever. So if you don't have the experience to develop your own templates or for AIC, it will be very hard to provision something like that. So that's why Microsoft had published, I don't know if you already heard about it or not, it's called Azure Verified Modules, AVM, which is an initiative by Microsoft to support open source developers who develop scripts on Terraform and Bicep globally. So this initiative allows those developers to share their scripts with Microsoft, and Microsoft will do a publishing and also do security check and also do consistent check and ensure that those scripts or modules compatible with Microsoft well-architected framework at the same time doesn't have risk and it works in production, no harmful actions that could happen. And then it's published, and keep the link of each published module where you can track on GitHub. You can track if you have like a specific module and you are a big fan of this module, you can clone this GitHub repository to your own, and also you can see the development cycle of this. Like for example, they keep updating the modules, adding new features, so you can also monitor the new changes and features released on this wiki. So this initiative, I find it very helpful if you wanted to deploy something complex like AI or any other platform. So let me show you how it looks like. before I continue. Okay, so this is the Azure Verified Modules portal. This is managed by Microsoft. And you can simply navigate through and find a module indexes. So we have two measures, one for Bicep and one for Terraform. So if you are interested to deploy something in Bicep, you can go here. In Terraform, you can also. So if I go to Terraform, for example, okay, by the way, they also here provides a lot of trainings, how you can import the modules, how you can run it on your own, how you can get clone the repository, a lot of things, very straightforward labs that you can train yourself how to use Azure Verified Modules, a lot of documentations, and also a community hub. So here you can see that I have options like resource modules and pattern modules. So resource modules means that I will find here a template to deploy specific resources. But in pattern modules, it will be something like landing zone deployment, for example, which has multiple level components to deploy. So if you go to a resource module, for example, you can find a list of most of the services or resources that you wanted to deploy. Okay, this is like a treasure where each one of these actually is developed by someone, and his name will be, you see here, this is the owner of this GitHub repository. He published, and he's responsible to maintain this healthy. And you see here that this is the available version and status, if it's still up and running or whatever. And this is all maintained by Microsoft. So if we go, for example, for AVM REST Cognitive Services account, where this script you can use to deploy Azure AI services in your production. Okay? So you can simply see that it has multiple examples that you can use to deploy. Okay, like for example, you need to deploy cognitive services with private endpoints, default V4 model, or with key customer managed encryption, blah blah blah. But you can simply go to this repository, and you will find the full projects available for you to download. So how you can use it? Simply you can run from your machine, git clone, and clone this repository local on your machine. Okay. Just one simple command, and it will download all of these modules. It has a README file, and this is mandatory by them to develop a README file to explain to you the modules, what it's going to create, and how you run it in your environment. So this is, you can have, once you have your own copy or clone from this repository, you can develop also, and you can edit it. It's up to you. So you may have a version or another version. You can upload it in your own Git repository, and then follow other versioning. So like you take a fork from this, and you can also own it and use it for other deployments. So from Terraform perspective, just you need to clone it, you need to initialize, and then pass the variables that is mandatory for this, or go through it, or make your own adjustments, and then run it in production. Okay. So this is one simple thing that you can start using it today. You don't need to develop from scratch. You may find it maybe very complex, but when you run it, you will find that the variables is very straightforward that you provide, and then it will go and create things. This one, for example, has like 4 or 5 default variables, like which AI service you want to deploy. If you want to deploy OpenAI, then just select OpenAI. location, resource group, and then the SKU size, 0, R1, whatever. And then it go and create the resource in your subscription. Good.
We keep these modules in our, for example, in our centralized modules, and it's verified because normally previously it's available in some addition, some arbitrary random GitHub repositories, which now Azure, now Microsoft is verifying that, okay, there is no security risk using these modules, centralized modules. We just import in our centralized repository, and then
you can fork it, you can keep it, and then when any changes or the new version has been released, you can update your own.
okay, so, but that's kind of the manual process to maintain, but it's a good approach. We have confidence.
Yeah. For example, if you go here, you can see the actions is being done. Okay, so you can see here the updates of this module.
Okay, yeah, so
happened. It has a bug. They updated. They added a new thing, so you can follow the historical. You can go back to previous fork or previous version if it's still available. But you can see what's happening, and also you can interact. You can open a support ticket for this with Microsoft. By the way, it's supported by Microsoft. If you
have this Azure verified module, okay, over there we can find.
You can open a support ticket, and also you can communicate with using issues. So you can use this to post something. Other community will help you to solve the problem if they are facing the same. And also the owner of this GitHub repository should also respond and provide some best practice or how to solve your issues. So it's very interactive community.
But I'm just because we don't have the Terraform support itself with HashiCorp. But if you go via this route,
Microsoft will not support Terraform. If it's like that, they will support you as long as it's something related to the AVM or something is published, but they will not provide you support for Terraform.
Yeah,
because it's Terraform. Yeah, so you can use Terraform.
But these owners will support if that is particular to their modules.
Yes, and they are very actually responsive. If you see the issues, for example, it has issues. If you go for this module specifically, I like this module because it's make my life easier when I deploy things. So you can see like issues and the ticket has been open, what is closed, open still 5 and closed 8 means some tickets has been open or issues and then it's already resolved. You can post your question here, your errors,
okay,
and the community will help you to fix, or the owner can help you to fix.
So whenever you do some utilize these modules, you bring these modules in your and then your exploration.
And also, it's open source means you can edit it and use it for your own benefits. Yeah, so this will provide you a treasure source for Bicep and Terraforms for a lot of complex scenarios. You don't need to waste your time and develop, just use it and run. Okay. So this is about the verified modules initiative. Okay. Yeah, and they have a lot of videos, communities, dashboard to see new modules. They are very, very actually active community. Also, you can participate if you have developed something and you wanted to publish it. You can publish it through the Azure verified modules. Microsoft will do the verifications. If it's accepted, then it can be published. I don't know if Microsoft pay for that or not, but this is how it is.
Be monetized.
I don't know that this open source community. I don't think, but maybe. Now, let's think in more an enterprise scale level. Okay, so you already developed your own scripts, you invested in it, but when it comes to the larger scale, like enterprise scale, you need to add some considerations as well. Okay, so here it comes DevOps and DevSecOps. Okay, so you should treat infrastructure as a code as any piece of code you have or within your development lifecycle within your organization. Okay, so you can use a technology like DevOps or GitHub repos to do a lot of things that make your infrastructure as a code more valuable. One thing is we make it published, mean it's accessible only by the people that should access this resource or this script within your organization. There is one step between running the scripts locally in your machine and centralize the scripts. You can either centralize the scripts in a storage account, for example, in your Azure. And whoever wanted to access this storage account or this script, he need to access the storage account, build the scripts, or run the scripts from there. Okay, and you can use something like linked templates, where you can run a template and you can refer to another template to be run, even if you don't have visibility to this template. So just you refer to this template, and then it will be called and run. For example, you are not owning the template that creates a storage account. You are owning the template that creating Azure AI service or VMs. But within your code, you can refer another template that you know the location for it, that it will do this provisioning for you once passing also the variables to this template. We call this linked templates. So you can use the same concept on storage accounts with the security with SaaS key access to secure the accessing to this storage to this scripts. And also you can do another more mature level is to use the pipelines and DevOps or GitHub repositories to create a repos of your code. Similar like we saw in that's Microsoft do for verified modules. You can do the similar within your organization to have your modules published and also to run some GitHub actions on this. So you can have something like DevOps pipeline or GitHub actions. When your script wanted to run something, some actions must be taken, for example. For example, to check the code within your scripts. Okay, so you need to run some tools that check if you have some sensitive information or you have DLP. Maybe you put some data that related to the company that shouldn't be exposed or something like that. So you need to run a kind of data loss prevention to check if you have provided some P1 or P2 information, some similar things like that. So you can integrate Microsoft Defender for Cloud or Sentinel with your GitHub, okay, where it can go and scan the code and ensure it's safe and secure. And also GitHub Advanced Security, it's one advanced features that it also do this before the template is being run and through Terraform and then access the Azure Resource Manager to create resources. So why it's important to have this in place is because your code is like, you remember the first thing, the idea of having IAC is to make your code distributable and reusable. So this makes this distributable and reusable. Okay. And also it can take actions inside the pipeline for verification or for other also taking action for example, approval. So before this script is being run in production, you need to get an approval first. So someone will be alerted that this code is going to be run. Do you approve it or not? So for example, this code could create a very huge environment that's very costly. So you need to ensure that it's not run by mistake, or you need to get an approval. You have budget for that or not. So this could be another approval cycle before it's being approved for this script or these modules to run in production. Okay. So also you can integrate other services like, as I mentioned earlier, Azure Policy, where you can use Azure Policy to governance also whatever you're going to create, ensure that only accepted resources with a specific configuration is done, and also Azure Monitor to log to see resource creations, accessing, permissions, leaks, all of these kind of things can be logged in the Azure, monitored by Azure Monitor, so you can see what's happening in your environment. So this is
I have a question. You were showing earlier about ARM testing, about security.
You can inject ARM testing here.
So yes, okay, that's one way, but this GitHub Advanced Security will do this to verify the Terraform scripts and check the security, or
No, you need,
Which part of
you need
it
to
is-
use this tool as part of your pipeline to do this test.
Okay, so it's a additional steps integrated to validate. But you are mentioning that this Azure policy can also be utilized instead of that because this in this way we are using the Terraform script.
Yeah,
That
but,
was for only for the ARM testing for this particular
yeah,
use case.
Azure policy should be regardless applied regardless which technology you wanted to deploy.
Okay,
Therefore,
survey. But that will happen once we provision the services and then it validate what it will do.
during the creation. You remember when you go in Azure portal and create a resource, it takes time to do verification before it gives you the option to create, right? This verification means it compare or it check if you have Azure policy or something blocking you from doing this action. It could be Azure policy, it could be you don't have quota, whatever. The validation process that's happening from the Azure side. This validation will always happen regardless you use GitHub or DevOps or run your own machine. Still, this validation will happen on the Azure Resource Manager level.
Right. So
Okay? And then Azure policy will do this kind of governance on top of the Azure Resource Manager. You may do something that is not accepted by ARM. You pass invalid values. So ARM will not accept it. But what if you passed accepted values, but by company policy is not accepted? So you need Azure policy to do this overall governance across.
Right. So if the resources doesn't have the tags, that is one of the policy that gets validated. But again, that's a good but again the security things that okay, if I have this storage account provisioned with all network allowed, can it be validated inside this policy?
Yes, Azure policy do two things actually, or many things. One of them is to do a compliance check. So you can say, okay, you will see in the Azure policy, you can see how many resources you have right now in production not complied with your Azure policy. Okay? And then you can take a remediation action. Like for example, it will not blocking you from creating a VM with public IP, but it will consider this VM as non-compliant. So you can do your Azure policy in this way to only audit. So it will just mark this resource as in compliance, and then you can take further action to remediate or fix the problem or keep it if you accept this as a risk for this specific VM. Or you can enforce the policy that this VM will not be passed through the Azure Resource Manager verification. It will be dropped. So even if you run it in a pipeline, it will be dropped because the Azure policy will block this VM. Right? Now, once you have all of this, you have to consider some golden rules when you use IAC development. Okay? Always use Azure policy. Don't count only on your code and DevOps pipelines and checks that is only enough for you to control creating resources in your environment. Also, always consider Azure policy as the policy restrictions. Also, implement RBAC permissions. So, I say when you do DevOps, for example, you create a service principal count for your DevOps to create resources or not, right? So you may provide this service principal extra permissions or permissions across all of the subscription that is not needed for this pipeline to run. So only you need to assign this pipeline a permission on a resource group level, for example. Right? Or user who is going to run the script, he only need to get permission only to run whatever he's allowed to create in using his own RBAC. Use always managed identity instead of user identity. Okay. Secure storage for secrets with Azure Key Vault. So you may in your code you need to have secrets provided. So you always use Azure Key Vault. Don't store SQL secrets or storage account secrets or VM secrets in the normal files. Always use Azure Key Vault for doing that. Right? And always use managed identity for automation. Okay? This is easy, and you can validate ARM and the Terraform code using when you run Terraform using LAN or ARM templates using the validations, or you can have something in your pipeline.
How many slides there?
2 left. Last one.
No, we are just asking.
Security scanning in Azure pipeline is something also you can use it integration with Defender. Activity logging and Azure monitoring. You can use Azure Sentinel, definitely. This is very good practice. You can, this will give you alerts when something suspicious or phishing is happening. And this also, I always recommended apply network security best practices, because network security, when it comes for routing UDRs, NSGs, firewalls, it also control how your services will be accessed and created. Okay, so you should make sure that you have all network security best practices and controls in place when resources being created, because if you keep things like unmanaged, you will figure out later on that you have a total mess in your environments. Things that shouldn't communicate with each other, they have access. Routing is not working in a proper way. Firewalls that should scan traffic is not actually in the bus way. Traffic is going in a different way. So all of this kind of things, when you have ISE used to deploy things, you have to consider also from the networking perspective, the subnetting, the VNets, the routing. All of this must be carefully considered. Otherwise, you will have a big issue. Okay, encrypted data and regularly audit. This is also one of golden rules that you should always act on. Okay, so this is the slides. Do you have any questions before I do the demo?
Only one question.
Yeah,
Go ahead. Go ahead.
Okay.
Okay. There is one question. Usually, like a lot of companies, when they start, like in Azure, let's say they start with manual deployment. So consider that the team is starting on their deployed, let's say, a dev environment. They want to like take that as a template to deploy in UAT in production. So is that easy? Like how that can be done?
Let me show you something. Okay. This one of the demo that I I was planning to do, but this is a new tenant that has been provisioned for me a couple of days. And when I was trying to build this demo, I figured out that something that the platform is missing, so I cannot run it in. I submitted a form, but it needs like 2 days to work. So, but this is simply how it is actually. So I already I just created a pipeline in my DevOps. Okay. So this pipeline actually is running a script from a GitHub repository that I already uploaded some scripts. So I already developed the scripts using my own machine. Okay, and then I use git commit to upload this to my GitHub repository. Okay? And then simply using the wizard, I just a few clicks, I created a pipeline. Within this pipeline, I already created also the service principal and tell DevOps, this is actually for ARM deployments, for example. Okay, so it will do the verifications, it will connect to my GitHub repository, and take the script from there and run it based on where this script is, what exactly this script is written for. Okay? So this is simply a very few steps that you can do, and then you can have something on GitHub. It's called a job. Okay? So in pipeline, you can go and create a new one. Okay, I can say like new pipeline. Okay, it could be something on GitHub. Okay, I connected my GitHub repository to my DevOps. So I can see here all my my repos. So I can select which repos I want to use, like for example this one, and it will show me okay what you want to do. I will make like a starter pipeline, for example. Okay, so here I can just simply these steps will be part of the pipeline. I can simply delete, and then provide some new variables. And I can select assistant. I can select here template deployment, for example. So this pipeline will do ARM template deployment. So I can select ARM template deployment. I can select the deployment scope where this script is going to run, which subscription, which management group, whatever. Okay. This already done. Why it has access to my Azure subscription? Because I already in the project settings, I already created a service principal. So this service principal is created in my Azure, giving permission to Azure, to DevOps, to access my environment. Okay. And then I can just fill in this information, like which subscription. I can select the subscription. This is the service connection I created earlier. So it's called ARM Pipeline Service Connection. I can list down the subscription that I have, and then the location would be like Sweden. I know, shit, I like Sweden Central. So I use Sweden Central. Okay. Okay, so I can here, instead of using linked artifact, I can use URL of the file. And then I can go to my GitHub repository. I can just simply, this is the script that I already created, ARM templates that I already created, developed on-prem, and I upload it to my GitHub repository. And then I can go to the row and take the link of this, JSON file. Okay, that it will do some actions. Then you can go to the DevOps back and then provide the link.
But just if you guys want to start it, I think just start with one simple thing. At least you get the idea. And then you start from a simple one, which is like easy to deploy. Start from a resource group or a service which is stateless, without network and things like that. And then you keep adding. So it will give you a practice how to do it. It takes a while, even like I don't know how to deploy this. I'm always after that. You can help me out. But yeah, it should be good practice to have this knowledge. One person cannot do each and everything, but at least to get the grips how to like start it, or if the Terraforms are there, what it's doing, how to like manage it. So I think this will.
Yeah, and look, thank you. Yeah, this is very good advice, because you can start from now. You see that you can get the templates from anywhere. It's available in Azure verified modules, or even you can use now ChatGPT. Okay, I did some fun, like a couple of days. I just copied architecture in ChatGPT and told them generate Terraform templates to deploy whatever you see in the image. And it gave me not the perfect thing, but it gave me some at least starter points just from the image. Just I provided the image, and it gave me a bunch of scripts I can use to create whatever I see in the image, and then use it. So with ChatGPT is now helpful, Copilot or whatever. You can use this technology to give you the starter of development. Then you can test with small thing in production, in test environments, in test subscription. Once you're confident, you can keep growing your knowledge, and then you can have like central. You will get the knowledge, you get the experience, and then you can feel confident to deploy in production, do whatever you want. So it will not, you'll not get these skills without applied. Yeah, go pilot integration in the DevOps in GitHub, and also in the Visual Studio, where it can help you to develop. So in GitHub, yes, it has also Copilot.
But it doesn't have this DevOps to write, for example, I want to write the pipeline.
I don't know. I don't use Copilot, but I believe it will come anyway.
It will come. I think it will come. Just to like deploy the code first. Which just should, if you started it, you ask to write the code. It will write the code, and then you just deploy it. But yeah, the pipeline and things like that, it will come. All the tools will have it, but when, that is the question.
Yeah.
So there is the Copilot, normal Copilot, and Copilot for security. Which one will be?
No, Copilot for security is for it works for Sentinels and things like that. But here it's
everyone has a different Copilot, like Copilot for 365,
Copilot for Azure,
Fabric, Copilot for Power BI. Everyone has a.
Have you used the Copilot for Azure before? You have in Azure, you have Copilot also.
I gave it many chances. It was never useful, honestly.
I use it also to generate KQ to get the Azure query.
Yeah, maybe for the logs.
Graph queries, this is amazing. I can ask like for example, give me a list of all storage account that has public access. And just go create this query for graph query for me and just list down all the services. So this kind of generating queries, I use it. Sometimes it's dumb, but for generating queries, I use Copilot here in Azure.
Are we almost done, David?
Yes. Do you have any questions?
Because the pizzas will be then cold.
Any questions?
Thank you.
Thank you, people who are online. And yeah, thanks for joining. Thank you, David. I think the pizzas are here, so you guys can now eat and enjoy during the pizza.
Thank you.
This must be